All right, so welcome to your first Sugaku lesson in our geometry unit. And the first learning objective that we're going to study is actually just some basic area formulas. We're going to talk about some basic area formulas. And then we'll go from there. There's going to be a total of 3 learning objectives. Actually, not take that back. Probably 2 learning objectives that you'll have in this particular Sugaku unit. But you'll see how that works. Anyways, basic area formulas. I'm going to show you some pictures, and we're going to talk about what it is, what area is. But let's start with what is area. Well, we should all know that basic area, and a lot of you are going, maybe it's the space inside, the amount of inside a figure, and that's all right and everything, but the formal definition of area is this. It's the number of square units needed to cover an object. So if I gave you a Pentagon, how many square units, literally square units, so let me show you. So if I gave you a basic pentagon, here's a basic pentagon, how many square units would it take to fully cover the shape? And I'm just being quick and general about that. They all should be the same, by the way. That's what area is. So let's talk about some basic. I think you should know most of these already. So let's see. We'll start with the real basic one, which is the square. And when I have a square, we know all the sides are the same, and we're going to say the side has a length of s. Now, if you think about that, it has a length of s, which means there are s units. So if I think about the square units needed to cover a square, I actually have my square units like this, and there's going to be s of those square units. But there's also going to be s of them going this way, because this side is also s square units. And I put those dots there to show that there's infinitely many, because there's s number of squares. Well, if there's s going down and s going across, the total number of squares then is going to be s times s, or the area of a square is the length of the side squared. The next shape that we're going to talk about is the rectangle. Now, the rectangle, pretty simply, looks like this, and we have a length and a width of a rectangle. And of course, we use the same philosophy as we do with the square. There would be L squares going along the length and W squares going up the width, which means in total, the area of a rectangle would be, say it. Now aren't you embarrassed that you said that with headphones on? I'm kidding. Length times width. Our third shape that we're going to focus on is the parallelogram. Now this one's kind of a cool shape and how it works. We have our basic parallelogram, kind of like this. And one thing you have to know about parallelograms is you need to have a base and you need to have the height. And the height of the parallelogram is a line that goes from from a vertex and is perpendicular to the base. So that is the height of the parallelogram. Now it could go the other way too. I could use, I could say that this side is the base, and I could go from here all the way, and it's kind of a tricky thing to do, but I could go from here and make it parallel to or perpendicular to that base. But we're going to keep to what we have here. But what's interesting is if I was to take this triangle, so if I was to take this triangle here, and I was to cut it off and move it to this side here, so that was the height. What's interesting is that this becomes, if you look at the shape now, it's this here, which is a rectangle. And we know from before the area of a rectangle is length times width, or in this case it would be length, which is the base, and the width is the height. So the area is base times height. Now, let's talk about our friend tri. You remember triangle? So triangles are kind of unique in that if I draw a triangle like that, again with a triangle, I have a base and I have a height that goes from the opposite vertex perpendicular to the base. And those are the two most important sides that I need. Now, what's unique about the triangle, and I don't think it's going to allow me to do this. No, it's going to take the whole thing. That's okay. What's unique about the triangle is if I was to take a congruent triangle and put it upside down along the other side, notice it shows up as a parallelogram. That was a congruent triangle, so that means that the triangle is actually half the parallelogram. So that means the area of the triangle would be base times height divided by 2. Because the triangle is half the parallelogram. The final shape we're going to talk about is a trapezoid. Good old trapezoid. And in a trapezoid, it's interesting with a trapezoid, because a trapezoid, we have base sub 1, the first base, and we have a second base. They're not the same, they're different. If they were the same, I'd have a parallelogram, but they're not the same. But I also have the height between the two bases. Now, like I do with the triangle, if I actually was to take a congruent trapezoid and turn it like, oops, I don't want to do it that way, turn it like that, again, notice what shape I have. I have a parallelogram. So right away I notice that the trapezoid is going to be half the area of the parallelogram. But the question is, what's the area of the parallelogram? Well, it's the base. Well, the base of the parallelogram is this whole thing here. I know this is B2, but how long is this here? That's right, it's B1. So this is B1 here. So that means the base of my trapezoid is my parallelogram, is B1 plus B2. And we know that the area of the parallelogram is the base, B1 plus B2, times the height, which is H. And because the trapezoid is half of that parallelogram, I divide it by 2. And so the area of a trapezoid is B1 plus B2 times H divided by 2. Now, these are just formulas. And the nice thing about formulas is all you have to do is plug in numbers to use them. So let me give you a couple of examples here. Let's start with these two first. This is a square with a side of 5. Here's a rectangle with a side of 7 and with a length of 7 and a width of 4. Pause the video and see if you can find the area of those two shapes. Okay, let's see how you did. The area of a square we know is a side, which is 5, squared. Well, 5 squared is just 25. And by the way, when we're doing area, it's units squared. Now, if I had said that was 5 centimeters, you would have said centimeters squared. But in this case, we're going to make it generic, so we'll just say units squared. The area here is length times width, or 4 times 7. And 4 times 7 is 28 units squared. Did you get those both right? Good. Take a look at these. Let's do a parallelogram. Side of 3, side of 6, and a height of 8. And let's do a triangle. 4, 5, 7, and the height's going to be 6. Okay, pause the recording and see if you can find the area of the parallelogram and the triangle. Okay, did you do it right? If you did the parallelogram, you would have realized in both these pictures, I've actually given you some extra information. You don't need the 3. That's excess. All you need for the parallelogram is the base, which is 6, and the height, which is 8, and 6 times 8 is 48 units squared. Let's look at the triangle. Again, I gave you extra information because I only need the base and the height, which means the 4 and the 5, that's extra information. I didn't need that. But the area is going to be 6 times 7, height times base, or base times height, divided by 2. 6 times 7 is 42 divided by 2, and 42 divided by 2 is 21 units squared. Hope you got both those right. So finally, we end with the trapezoid. And with the trapezoid, I'm going to tell you this is 4, this is 7, and this is, let's call this 6. All right, again, pause the recording and see if you can come up with the area of the trapezoid. All right, if you did it right, you said that the area was base sub 1, 4, plus base sub 2, 7, times the height, divided by 2. 4 plus 7, I'll do that first. That gives me 11 times 6 divided by 2, which is just 66 divided by 2, or 33 units squared. And there's my answer. That ends our first video. Look on Google Classroom and it will tell you what activities I want you to do, and you can go from there.